This is the Chapter 5, Unit 1A test review. Oh, I wrote test review twice. There we go, all fixed. Sorry, number 12 through the performance assessment task at the end of the review. Number 12 says, what are the zeros of the following polynomial function if a, b, and c are positive numbers? Well, it doesn't matter what, why did it say a, b, and c? There's no c. All right, it doesn't matter that there are no numbers there. When you're trying to find the zeros, you set each of the factors equal to 0. And there are 3 of them here. Not that there are 3 factors, there really are 4, but one of them is a multiplicity of 2. So one of the solutions is x equals 0. The next one is x is equal to negative a, and that one is the multiplicity of 2. And the third answer is going to be x equals negative b. And those are the zeros. In problem 13, they want you to solve 5x plus 6 is equal to x minus 2 squared minus 1. There are 2 ways of going about doing this, and they both require a little bit of work. One of the ways of doing this, or if you're unsure of how to algebraically manipulate a problem, you can put one side of the equal sign into y1 equals and the other side into y2 equals, and find where the graphs intersect. Here's the problem with this problem. If you graph 5x plus 6 and y1 equals and x minus 2 squared minus 1 and y2 equals, the only thing that you're going to see on your screen is this point of intersection. And you won't know that there's a second point of intersection unless you actually change the window on your screen. So the window on my screen I've already changed, and we can see that the 2 solutions are at x equals negative 0.32 and at x equals 9.32. So for this case, because there are 2 solutions and you can't actually see them both, you might be better off actually multiplying out the polynomial and getting it equal to 0. So what I would do is I would start with x minus 2 squared. Remember, that's x minus 2, x minus 2. If you don't do that, you're going to accidentally think that it's x squared minus 4 or x squared plus 4, which it's not. It's x squared minus 4x plus 4. Okay, next, we want this equation to equal 0, and probably the best way to do it is to move the 5x and move the 6. So we're going to make the left-hand side equal 0 because it really doesn't matter which side equals 0. And you're left with x squared minus 9x. 4 minus 1 is 3, and 3 minus 6 is negative 3. So instead, you could graph this and find the x-intercepts. And now if you look at this picture, that's going to show up on your screen without having to change the window. And look, my x-intercepts, are at negative 0.32 and 9.32. Number 14, it says let f of x be a trinomial function with a positive leading coefficient. Which of the following would not be a possibility for the number and type of solutions? I think that the review question is poorly worded. The question on the test is better. So here's what I need to go over for you to be able to answer this question on the test. So let's talk about quadratics for just a moment. Quadratic functions are ones whose biggest exponent is x squared. If it's positive x squared, the graph opens up, and if it's negative x squared, it opens down. There are at most 2 real zeros, but there could be 2 complex zeros, with imaginary numbers. There cannot be 1 real and 1 complex because I mentioned in class that complex solutions always come in pairs. Please remember that. You can have no complex solutions. You can have 2, 4, 6, 8, but you cannot have 1. Now, with cubic functions, the graphs either go up from left to right or they go down from left to right. The least number of times that a cubic function can hit the x-axis is once. So it can have as few as one real solution. It has to have one real solution because the fact that the graph goes up and down forever means it has to pass through the x-axis at some point in time. So if it has one real solution, then the other two are complex. Otherwise, it's going to have three real solutions. That's the only other thing that can happen. And the reason is because, remember, you can't have one complex solution. It's either two or some other even number. Quartic functions, polynomials of degree 4, or m's or w's, but they could also be parabolas. Here's the thing, because both ends open up or down, there's the possibility that it could have 4 complex solutions. That means it never hits the x-axis at all. And then, or it could have a double root, so it can have 2 complex and 2 real. Let's see, yeah. Or it can have 4 real and no complex. Quintic or degree 5 polynomials. Let me remind you that that is quintic, and this one is called quartic. Quintic functions, anytime the biggest exponent is odd, one end will go up and one end will go down, depending on if it's positive or negative. It has the same properties as did the cubic functions. So this could have 4 complex zeros and 1 real. Or it can have, I'm running out of space, 2 complex and 3 real. Or it can have no complex and 5 real. Complex solutions have to come in pairs. And since the total number of zeros has to be the same as the biggest exponent, you can figure out how many real and how many complex it has. When factoring, you always have to take out the greatest common factor first. I know I showed you a way of doing it on the graphing calculator to help you, and that's great, only if you factored out the greatest common factor first. So I want you to look at these 3 terms, and I want you to notice all 3 of them are divisible by 2 and x. So the greatest common factor is 2x. When you take those out, you're left with x squared minus 5x plus 4. Now if you want to go use the graphing calculator to help you factor that, you can, but you shouldn't have to, because this is a simple trinomial where you look for 2 numbers that multiply to give you 4 but add to give you negative 5. And those 2 numbers are negative 4 and negative 1. However, if you graph this in the calculator, you'll find that it hits the x-axis at 4 and negative 1. It's just that if you go and graph this on the calculator, you're going to see it hit at 0, 4, and 1, and you're going to forget that part of the factored form must include this 2 that comes from taking out the greatest common factor. In problem number 16, it says a rocket is launched into the air. Its height can be modeled by the function negative 16t squared plus 75t plus 10. 3 seconds later, another rocket is launched, its height being represented by the function r of t is equal to negative 16t minus 3 squared plus 50t minus 3 plus 10. How long after the first rocket is launched will the 2 rockets collide? The point where they collide is the point of intersection of the 2 graphs. So what I did was I put one of my functions into y1 equals. I put the second function into y2 equals, and I searched for the point of intersection. Now I want you to notice that on the graphing calculator, you'll have to play with the window in order to find it. My graph, I needed it to go up to at least 50 for the y maximum, and then I was able to find that the point of intersection is at 4.141 seconds. How do I know which answer I'm looking for? Well, the input was t and the output was h, so t must be your x. To determine if something is a root of a polynomial or not, you want to know if its remainder is 0. So if negative 2 is a root of x squared plus x minus 10, then the remainder will be 0. And there are two ways of showing this algebraically. One way, the rational root theorem, says that if you plug negative 2 in for x, it's called the remainder theorem. If you plug negative 2 in for x, whatever value it equals would be the remainder. So 4 minus 2 minus 10 is not 0. The remainder would be negative 8. So another way you could do it is you could put negative 2 in the little box and perform synthetic division. The coefficients are 1, 1, and negative 10. Drop the 1. Multiply, you get negative 2 here. Add going down, multiply, add going down. The last number is always the remainder. In either case, negative 2 is not a root. Not because the remainder is not 0. Number 18 asks the question, when can you use synthetic division and when can you not use synthetic division? You can use synthetic division when the divisor is in the form x minus a. In other words, it's got to be a linear factor. If it's not a linear factor, then you can't use synthetic division. You have to use longhand division. So you cannot use, I'm going to abbreviate this, synthetic division, when the divisor is not linear. In other words, let's say I asked you to divide by x squared plus 5. You could not use synthetic division if that's what you were dividing by. You would have to use longhand division. In number 19, we want to factor 2x cubed minus 7x squared minus 17x plus 10 completely. And right now, we don't have a lot of methods for factoring. In the second half of this unit, I'm going to show you another way to help you factor. But for now, I want you to always try graphing it and finding the zeros, because that's going to help us write this in factored form. So I graphed this on Desmos, and then I clicked where the intersects, or the x-intercepts were at. So I found out the solutions are x equals negative 2, x equals 0.5 is 1/2, and x equals 5. Therefore, the factors are x plus 2, x minus 1/2, and x minus 5. But we don't like fractions, and all you have to do is take that denominator and write it in front of the x. So the factored form would be x plus 2, 2x minus 1, and x minus 5. And that's how I used the graphing calculator to help me factor. Now, remember, on your graphing calculator during the test, you're going to make y2 equal to 0, and you're going to find the points of intersection of your graph with the x-axis. Number 20. If the polynomial x cubed plus 4x squared minus 7x minus 10 expresses the volume in cubic inches of a box, and the width is x plus 1 inches, what are the dimensions of the box? Well, there are two ways you can go about doing this to find the length and the height. One way you can do it is by using synthetic division. Negative 1 would go in the box, And next to the box would go 1, 4, -7, -10. You would drop the first number, then you multiply, and then you add, and then you multiply, and then you add, and then you multiply, and then you add. If x plus 1 is one of the dimensions, then the remainder better be 0. The quotient would be x squared plus 3x minus 10. And then you could easily factor that by finding the two numbers that multiply to give you -10 but add to give you 3, which would be x plus 5 and x minus 2. And so that would be your other two dimensions, and it doesn't matter which one's length and which one's width. A simpler method would be to actually have just graphed this in the calculator, in which case you would have seen it hit the x-axis at -1, -5, and +2. And then you would have known the factors were x plus 1, x plus 5, and x minus 2. Either method is acceptable. In problem 21, I've changed this equation just a little. It said x in parentheses. That was weird, so I made it h of t. The all-star kicker kicks a field goal for a team, and the path of the ball is modeled by h of t is equal to -16t squared plus 30t. That means the path of the ball is parabolic because this is a quadratic equation. Find the realistic maximum and minimum values for the path of the ball. Well, that's the same as when we asked you for a domain and range. We know the path of the ball is going to look like this. So we want to know how high and low the ball can go, because there's a maximum height. The minimum height is the easy part, because the height minimum is going to be 0. We just don't know what the maximum is yet. And how about the horizontal distance? Well, if you're starting over here, we're going to call this 0. So you're going to start at 0 because you're not kicking the ball behind you. And even if you do kick it behind you, we never call that distance negative. Well, we can't, because that would be time is now. I'm sorry, this is time and height, isn't it? So we can't kick it behind us because the time would still be positive. But we want to figure out at what time it hits the ground. Well, we have an algebraic way of doing this. Remember, x is equal to -b over 2a. That's the equation for finding the x value of the vertex or highest point. So, -b over 2a is going to give me -30 over -32, which is going to give me 0.9375. Well, that is the x value of the vertex. Now we want to find the y value of the vertex by plugging this into the original equation. -16 times 0.9375 squared plus 30 times 0.9375 is going to be approximately 14.1. So we know that the ball can go as high as 14.1 feet or as low as 0 feet. How about the realistic time? Well, you know, when you don't kick the ball, it's 0 seconds. But we want to know how long it's going to take before the ball hits the ground again. Well, if you set the equation equal to 0, and you factor out the greatest common factor, matter of fact, I'm going to cheat. I'm just going to do it this way. I'm just going to factor out t. You can factor out more than t, but I'm being kind of lazy here. T equals 0 is your minimum time. And to find your maximum time, you're going to do -16t plus 30 equals 0. So -16t is equal to -30. So t is equal to 30 divided by 16, which is approximately 1.875 seconds. The other way of doing the problem is to graph it in your calculator. The reasonable time, remember that the x-axis is t, would be from 0 to 1.875 seconds. And your reasonable height is going to be from 0 to 14.063, or approximately 14.1 feet. Number 22 says, looking at the following graph, what could be the first possible term if the polynomial is written in standard form? Well, the easiest one to pick is positive x cubed, because it only hits the x-axis 3 times and it goes up from left to right. However, it also could be positive x to the 5th, or positive x to the 7th, or positive x to any odd numbered power. Now don't worry, on the test, there's only going to be one reasonable answer. In problem number 23, it says if a and b are positive numbers, what is a possible equation for the following graph? Now here's the thing, they don't tell you, they say that a and b are positive and they don't tell you where they are. I think the fact that it says if a and b are positive is going to be confusing because you're going to think that that means the factors are necessarily positive. Here's the thing. One of the points is in the negative region and one of them is in the positive. So if this is a and this is b, then the factor over here is going to be x plus a, and this one's going to be x minus b, and they're both multiplicity 2, so this would be the answer. But because they don't tell me where a and b are, what if I said that this is b and this is a? That would mean the factors are going to be x minus a squared and x plus b squared. So that could also be the answer. Problem 24. A roller coaster's track is designed so that it can be modeled by the function h of t is equal to t to the 4th minus 6t cubed plus 9t squared minus 5, where h is the height and t is the time. The roller coaster motion lasts for 3 seconds, and safety laws say that the roller coaster can't go more than 250 feet in the air. Analyze the graph and describe any errors in the model if there is one. Well, here's the thing. If the motion of the roller coaster is from 0 to 3 seconds, that means that it goes from here to here. I want you to notice how high the roller coaster is. It's underground, isn't it? Because the x-axis is the ground. So, can you have a roller coaster underground? You can. What I can tell you is that because this roller coaster only lasts for 3 seconds, it won't hit the maximum of 250 feet in the air, in which case it's abiding by the safety laws. And now for the performance assessment task. Part A says write a polynomial function in factored form with 3 distinct zeros where 2 are positive and a negative 1 which has a multiplicity of 2. So this is what I did. I said, okay, here are my zeros. I'm going to have positive 2, positive 1, and negative 5, and the negative 1 has the multiplicity of 2. So in factored form, this would be x minus 2, x minus 1, and x plus 5 squared. In part B, they asked me to write my function in standard form. In other words, I need to multiply it out. So this is what I'm going to do to multiply it out. Since this multiplicity of 2 is the same thing as writing it twice, I am going to multiply these together and multiply these together, because you can only ever multiply 2 factors at a time. Let's use FOIL. X squared minus x minus 2x plus 1 is x squared minus 3x plus 1. Now let's multiply the other two together. X squared plus 5x plus 5x plus 25 is going to be x squared plus 10x plus 25. Now to finish multiplying these together, I'm going to use my little box method. I use a different color here. Remember when I use the box method, what I'm doing is I'm finding the areas of all the boxes inside, and then I'm going to add all those areas together. So x to the fourth, 10x cubed, 25x squared, negative 3x squared, negative 30x, and negative 75, x squared, 10x, and 25. Of course, I wasn't careful. This should be an x, so that shouldn't be x squared. That should be x cubed, x squared, and then that's an x. Now I'm good. All right. So my biggest term is x to the fourth. Then I have plus 7x cubed when I add those together. 1, negative 30, and 25 is going to be negative 4x squared. And now I'm finding another problem with this. So let me do this. Go backwards here. I'm sorry that I'm making a mess of this, but at the same time, please note that I make mistakes too. This should be a 2, because negative 2 times negative 1 is positive 2. Now I'm going to try this again. X squared, negative 3x, and 2, and x squared, 10x, and 25. Now make myself my box. And now everything should end up correct. X to the fourth, 10x cubed, 25x squared. Negative 3x to the third, negative 30x squared, negative 75x. 2x squared, 20x, and 50. Now I'm happy. So I have x to the fourth, plus 7x to the third, minus 3x squared, minus 55x plus 50. That is the polynomial in standard form. So then when we get to part C, the question is, what's the degree of my polynomial? Well, I have a fourth degree polynomial. What is the number of terms of my polynomial? I have 1, 2, 3, 4, 5 terms. What's the leading coefficient? The leading coefficient is the coefficient in front of the term with the highest exponent, which in my case happens to be 1. What is the end behavior? Remember, I don't need to graph it to determine the end behavior. It's a positive fourth degree polynomial, which means both ends go up. So as x goes to infinity, y goes to infinity. As x goes to negative infinity, y also goes to positive infinity. And what are the number and types of roots? Well, that one, I'm going to go back to the beginning. There are 4 roots. It's just that one of them is a double root, or a multiplicity of 2. So if I graph this, it'll only hit the x-axis 3 times. It's just here, when the graph hits the x-axis, you're going to see it bounce off. So the number and type of roots, it's going to be 4 real roots. It's just that one is a multiplicity of 2. You don't really have to say that. You could just say 4 real roots. That is the review for the Chapter 5, Unit 2A test.